Basics of Functional Programming and Scala. Learning Objectives. By the end of this lesson, you'll be able to describe and demonstrate programming with Scala, define functions, anonymous function, and class in Scala, use the different types of collections, and describe and demonstrate Scala REPL, or read, eval, print, and loop. Introduction to Scala. Let us discuss about the programming language called Scala. Let's begin. What is Scala? Scala is an object-oriented and functional programming language designed to demonstrate the common programming patterns in a concise, refined, and type-safe way. It is basically an acronym for Scalable Language. Scala is an easy-to-learn language and supports both object-oriented programming as well as functional programming. Here's some of the features of Scala. It's object-oriented. It is functional. You can extend it. It is statically typed. It runs on a Java virtual machine, and it processes concurrently. Let's find out more about its history and popularity. Scala is a general-purpose programming language. It was created and developed by Martin Orderski. Martin started working on Scala in 2001 at the École Polytechnique Fédérale de Lausanne, or EPFL. It was officially released on January 20th, 2004. Scala is not an extension of Java, but is completely interoperable with it. While compilation, the name of Scala is derived from the word scalable, which means it can grow with the demands of users. Scala files translates to Java bytecode and then runs on a Java virtual machine, or JVM. Twitter has announced that it has switched large portions of its backend from Ruby to Scala and intends to convert the rest. Apple uses Scala in certain teams along with Java and the Play framework. There are teams within Google that use Scala, mostly due to acquisitions such as Firebase and Nest. The Walmart in Canada uses Scala for their back-end platforms. And the New York Times revealed in 2014 that its internal content management system, Blackbeard, is built using Scala, Akka, and the Play framework. Why is Spark programmed in Scala? Spark itself is programmed in Scala for the following reasons. First, Scala is an object-oriented language. Scala is also a functional language. Scala can be seamlessly integrated with Java. And Scala is widely used for big data platforms and development of frameworks such as Akka, Scalding, and Play. With Scala, Spark can be embedded in any JVM-based operational system.
Scala installation. In this demo, we will learn how to install Scala in Ubuntu. Open the terminal and check if you have Java installed, since you will need JDK to install Scala. Check it using Java --version. This will show the Java version installed. If not, it will prompt an error as shown. As you can see, Java is not installed in the system. To do so, update all the packages using sudo apt-get update. Now install the default JDK using the command sudo apt-get install default-jdk. Press Y to continue. This may take some time to install all the dependencies required. Once this is done, you can now install Scala using the command sudo apt-get install Scala. Press Y to continue. This may again take some time to install the dependencies. Type Scala in the command prompt and press Enter. You can now see the Scala REPL running, and this confirms the successful installation of Scala. Let me give you a quick recap of the steps performed. Step 1. Open the terminal and check if Java is installed using Java --version. Step 2. Update all the packages using sudo apt-get update. Step 3. Install default JDK using sudo apt-get install default-jdk. Step 4. Install Scala using sudo apt-get install Scala. And Step 5. Type Scala to start the Scala REPL and confirm the successful installation.
Functional programming. We've been referring to Scala as a functional programming language. Please brief me on the details. Well, start with functional programming languages are designed on the concept of mathematical functions that use conditional expressions and recursion to perform computations. It also supports higher order functions and lazy evaluation features. Functional programming languages are categorized into two groups. One is pure functional languages. These types of functional languages support only the functional paradigms. For example, Haskell. And then there's also impure functional languages. These types of functional languages support the functional paradigms and imperative style programming. For example, Lisp. What are some of the advantages of functional programming? One is it offers bug-free code. Functional program does not support state, so there are no side effect results, and we can write error-free code. Also, efficient parallel programming. Functional programming languages have no mutable state, so there are no state change issues. One can program functions to work parallel as instructions. Such coding supports easy reusability and testability. And efficiency. Functional programs consist of independent units that can run concurrently. As a result, such programs are more efficient. And it supports nested functions. Functional programming supports nested functions within the code. Lastly, lazy evaluation. Functional programming supports lazy functional constructs such as lazy lists, lazy maps, and so on. So, what is the difference between functional programming and object-oriented programming? Well, functional programming uses immutable data, where object-oriented programming uses mutable data, or data that can be changed after it's created. Functional programming supports parallel processing, but object programming does not support parallel processing. In functional programming, flow control is done using function calls and function calls with recursion, whereas in object-oriented programming, flow control is done using loops and conditional statements. Functional programming supports both abstraction over data and abstraction over behavior, whereas object-oriented programming supports only abstraction over data. Functional programming follows declarative programming models, and object-oriented programming follows imperative programming models. Programming with Scala. Data types. Scala supports the same data types as Java does, with the same precision and memory footprint. The table on the screen lists and explains all the basic data types used in Scala. These are byte, short, int, long, float, double, char, string, unit, null, Boolean, any ref, and nothing. Basic literals. The rules used by Scala for literals are easy and intuitive. Let's first discuss the integer and float type of literals. Integer literals are of int, long, short, and byte types. They are available in two forms, decimal and hexadecimal. There's an example given on the screen. On the other hand, floating point literals contain decimal digits. They may optionally have a decimal point and may optionally be followed by an e and an associated exponent. A few examples for defining such literals are given on the screen. Other types of literals are character literals and string literals. Character literals contain any Unicode character between single quotes. There are special character literal escape sequences, and an example is given on the screen. Another type of literal is the Boolean type that has literals true and false. A few examples for defining these literals are also on the screen. One more type is symbol literals, which are written with idents. An ident can be any alphanumeric identifier. An example of it is given on the screen. String literals contain characters surrounded by double quotes. A few examples to define these literals are also on your screen. Introduction to operators. An operator is a symbol that conveys to the compiler that it needs to perform specific logical or mathematical manipulations. Actually, these operators provide a nice syntax for general method calls. For instance, consider the example on the screen. In this example, the class int includes a method called plus that takes an int and provides an int as a result. To invoke the plus method, you need to add two ints as depicted in the example. Scala provides a rich set of built-in operators. The first type of operator is arithmetic operators, which allows you to invoke arithmetic methods using infix operator notation for addition, subtraction, multiplication, division, and remainder on a numeric type. The next type is relational and logical operators. Using these operators, you can compare numeric types, such as greater than, less than, greater than or equal to, and less than or equal to. All of these methods provide a Boolean result. Additionally, you can use the unary operator for inverting a Boolean value. Bitwise operators allow you to perform operations on individual bits of integer types using bitwise methods such as bitwise and, bitwise or, and bitwise exclusive or. You can also invert each bit in its operand using any unary bitwise complement operator. The object equality operators allow you to compare two objects for equality using either the double equal operator or inverse.
Basic literals and arithmetic operators. In this demo, you'll learn the basic literals and arithmetic operators in Scala. To do so, open the terminal and type Scala to start the Scala REPL. Let us first learn how to use the basic literals. Here we are going to declare and use literals such as long, float, character, and string. For this, we will use the printline statement. We will declare the long variable. Based on the value of the variable, Scala automatically detects the data type. To define the float variable, you need to use the character f. In tick marks at the end of the variable value. By doing so, it will let Scala make the variable as float. Otherwise, it will be treated as a long variable. If a variable's value contains only one character, then Scala treats that variable as the char data type. If a variable's value contains more than one character, then Scala treats that variable as string data type. Let us see how to print a string in the console. Now let us understand how to declare and use the Boolean literals and use different types of arithmetic operators in Scala. Scala automatically detects a Boolean data type if the value is either true or false. Let us now look at the use of arithmetic operators like addition, multiplication, division, and subtraction. Scala automatically selects the data type for the result. If you specify a data as the long data type, you need to use the L character. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to run the Scala REPL. Step 2. Declare basic literals. Step 3. Print a string in the console. And Step 4. Declare the Boolean literal and use different types of arithmetic operators. Logical operators. In this demo, you will learn how to use logical operators in Scala. Here we are going to use different logical operators such as equal, greater than, and less than in Scala. To do so, open the terminal and type Scala to run the Scala REPL. You can perform the bitwise operation in Scala using the ampersand character as shown on the screen. To perform the equality check, you can use the equal. You can also use other logical operators such as greater than sign and less than sign. Many logical operators can be combined in a statement as shown. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to start the Scala REPL. Step 2. Perform bitwise operation using the ampersand operator. Step 3. Perform equality check using equal operator. And Step 4. Perform other logical operators like greater than and less than.
Type inference, classes, objects, and functions in Scala. Scala provides a built-in mechanism called type inference, using which you can omit certain types of annotations. For example, it is generally not required to specify the variable type, as a compiler can deduce it from the initialization expression of a variable. In addition, you can also omit return types of methods, as they correspond to the body type and can also be inferred by the compiler. An example to define the type inference is given. For val x, you can see the inferred type is int. For val y, because we have x to string, the type of inferred value is string. The final value of x plus 1 return is returning it as an int. Objects. An object is a named instance with members like methods and fields. Scala has singleton objects instead of static members, which is a class with only one instance and can be created using the keyword object. An object is a class that has exactly one instance. It is created lazily when it is referenced, like a lazy val. An object is a value. The definition of an object looks like a class but does use the keyword object. The example shows an object with a method. The method info can be imported from anywhere in the program. Creating utility methods like this is a common use case for singleton objects. An object with the same name as a class is called a companion object. Conversely, the class is the object's companion class. A companion class or object can access the private members of its companion. Classes. Classes in Scala are blueprints for creating objects. They can contain methods, values, variables, types, objects, traits, and classes, which are collectively called members. A minimal class definition is simply the keyword class along with an identifier. Class names should be capitalized. The keyword new is used to create an instance of the class. User has a default constructor which takes no arguments because no constructor was defined. Once a class is defined, objects can be created from this blueprint by using the keyword new. Functions. Scala provides a rich set of built-in functions and allows you to create user-defined functions also. In Scala, functions are first-class values. These can be returned as a result or passed as a parameter. You can create functions by using the def keyword. You must mention return type of parameters while defining functions, and return type of a function is optional. If you don't specify the return type of a function, the default return type is unit. You can see an example function called sumInts. This function simply detects whether A is greater than B. Anonymous functions. An anonymous function is an alternative of named function definitions for small argument functions that tend to get created by parameterization by functions. It is an expression that evaluates to a function. These are defined without giving them any name. An example of such a function is on the screen. Higher order functions take other functions as parameters or return a function as a result. This is possible because functions are first-class values in Scala. Map is an example of higher order functions in Scala. Double salary is a function which takes a single int, x, and returns x times 2. In general, the tuple on the left of the arrow operator is a parameter list, and the value of the expression on the right is what gets returned. On line 3, the function double salary gets applied to each element in the list of salaries.
Demo 4. Type inference, functions, anonymous function, and class. In this demo, you will learn how to define type inference, functions, anonymous functions, and class in Scala. To do so, open the terminal and type Scala to run the Scala REPL. First, we will learn how Scala can infer the type of variable based on the type of operations and data. Now let us see how to define a function in Scala. Here, the function name is sumInts, which takes an integer parameter and returns an integer value. In Scala, small argument functions can be used as anonymous functions. Let us see how. Now let us see how to define a class and implement some methods inside it. Classes in Scala are static templates that can be instantiated into many objects at runtime. Here we are declaring a class which takes two integer variables as parameters and has a method called addition, which will increase those two integers by 1 and print them in the console. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to start the Scala REPL. Step 2. Infer the type of variable based on the type of operations and data. Step 3. Define a function and anonymous function in Scala. Step 4. Define a class and implement some methods inside it.
Collections. As discussed, a map is an example of higher order function. But what exactly is a map? Map is a type of collection, so let us first look at what are collections. Collections are containers of things that can be sequenced as linear sets of items. Collections may be strict or lazy. Lazy collections have elements that may not consume memory until they are accessed, like ranges. Collections can be of the following categories: mutable collection, which is a mutable collection that can be updated or extended in place. This means you can change, add, or move elements of a collection as a side effect. Immutable collection. Immutable collections, by contrast, never change. You have still operations that simulate additions, removals, or updates, but those operations will in each case return a new collection and leave the old collection unchanged. Types of collections. 1. We have lists. 2. We have sets. 3. Maps. 4. Tuples. 5. Options. And 6. Iterators. Let us see all the types of collections that we have one by one. Types of collections. Scala lists are quite similar to arrays, which means all the elements of a list have the same type, but there are two important differences. First, lists are immutable, which means elements of a list cannot be changed by assignment. Second, lists represent a linked list, whereas arrays are flat. The type of a list that has elements of type T is written as list left bracket T right bracket. The example shows a list of strings and a list of integers. Sets. Sets are iterables that contain no duplicate elements. In other words, Scala set is a collection of pairwise different elements of the same type. Examples of sets is as shown. Sets have the following fundamental operations. Tests, which operations include, contains apply, subset of. The contains method asks whether a set contains a given element. The apply method for a set is the same as contains, so set left parent elem right parent is the same as set contains elem. That means sets can also be used as test functions that return true for the elements that they contain. Also, additions include plus and plus plus, which add one or more elements to a set, yielding a new set. Removals include minus and minus minus, which remove one or more elements from a set, yielding a new set. And set operations, which include union, intersection, and set difference. Maps. A map is an iterable consisting of pairs of keys and values. Scala's predef object offers an implicit conversion that lets you write key dash right bracket value as an alternative syntax for the pair key, comma, value. The fundamental operations on maps are similar to those on sets. The first example shows an empty hash table whose keys are strings, with the values being integers. The second example is a map with both keys and values. Maps have the following fundamental operations. Lookup operations are apply, get or else, contains, and is defined at. These turn maps into partial functions from keys to values. Additions and updates are plus, plus plus, updated, each of which lets you add new bindings to a map or change existing bindings. Removals are dash, 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 which remove bindings from a map. Subcollection producers are keys, key set, keys iterator, values, values iterator, which return a map's keys and values separately in various forms. And transformations are filter keys and map values, which produce a new map by filtering and transforming bindings of an existing map. Tuples. In Scala, a tuple is a value that contains a fixed number of elements, each with a distinct type. Tuples are immutable. Tuples are also especially handy for returning multiple values from a method. Tuples are also used for accessing the elements and pattern matching. The first example shows a val t, which is a tuple of different integers. The second tuple, val t, is a tuple containing integer, string, and console. Option. Scala option, left bracket t, right bracket, is a container for 0 or 1 elements of a given type. An option left bracket t, right bracket can be either some, t, or none object, which represents a missing value. Option type is used frequently in Scala programs, and you can compare this with the null value available in Java, which indicates no value. Iterators. An iterator is a way to access the elements of a collection one by one. The two basic operations on an iterator are nextAnd and hasNext. A call to it.next will return the next element of the iterator and advance the state of the iterator. Calling next again on the same iterator will then yield the element one beyond the current one that was previously returned. An iterator is a way to access the elements of a collection one by one. Here we see next and hasNext, which is used to find if there are more elements that we can return.
Types of collections. In this demo, you will learn how to use the different types of collections such as list, set, map, tuple, and option in Scala. To do so, open the terminal and type Scala to run the Scala REPL. To define a list, use the list keyword and pass elements as parameters. Similarly, you can use the set and map. See the syntax used for defining a map. A Scala tuple combines a fixed number of items together so that they can be passed around. Unlike an array or a list, a tuple can hold objects with different types, but they are also immutable. Here is an example of a tuple holding an integer and a string. An option is a container for 0 or 1 element of a given type. An option can be either some, in brackets t, or none object, which represents a missing value. Let us create an object test. That will have a main method to print characters from A to D. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to start the Scala REPL. Step 2. Define a list and pass elements as parameters. Step 3. Similarly, define set, map, and tuple. Step 4. Create an object that will have a main method to print characters from A to D. Operations on list. In this demo, you will learn how to perform different operations on list by using head, tail, and isEmpty methods. To do so, open the terminal and type Scala to run the Scala REPL. Let us declare an object test. Here is a class for immutable linked lists representing ordered collections of elements of type. This class comes with two implementing case classes, Scala, nil, and Scala : That would be a Scala : This implements the abstract members isEmpty, head, and tail. This class is optimal for last in, first out, or LIFO, and stack-like access patterns. If you need another access pattern, for example, random access or FIFO, consider using a collection more suited to this than a list. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to start the Scala REPL. Step 2. Declare an object. Step 3. Declare a class for immutable linked list representing ordered collections of elements of type. Step 4. Use collections if you need another access pattern.
Scala REPL. The Scala REPL is a tool evaluating expressions in Scala. The Scala command will execute a source script by wrapping it in a template and then compiling and executing the resulting program. Some of the features of REPL include the REPL's IMain, which is bound to $INTP. Last exception is bound to the REPL's last exception. / print tab is used to show typed desugarings. :help is used for a list of commands. :load is used to load a file of REPL input. And :paste is used to enter a class and object as companions. A few more features of REPL. :paste with a -raw is used to disable code wrapping to define a package. $JavaP is to inspect class artifacts. -Y REPL -outdir is used to inspect class artifacts with external tools. :power is used to enter power mode and import compiler components. :settings is used to modify compiler settings. Some settings require :replay. And :replay is used to replay the session with the modified settings. Implementation note.
The following are the implementation noted of Scala REPL.
User code can be wrapped in either an object or a class. The switch is Y REPL-class-based. Every line is compiled individually. Automatically generates imports includes the dependencies on previous lines. And implicit import of Scala.predef can be controlled by inputting an explicit import. On this screen, we see an example of Scala REPL, which imports predef to add an object to a string.
Scala REPL. In this demo, we will demonstrate the features of Scala REPL. To do so, open the terminal and type Scala to run the Scala REPL. Let us now look at a few features of Scala REPL, starting from $INTP. Type $INTP and press Enter. The output shows that REPL's IMain is bound to $INTP. Print is used to display a message on the console. The :help command is used to display the list of commands as shown. The :load command is used to load a file of REPL input. Suppose you have a file named abc.txt. You can load the file using the :load -v abc.txt command. The paste command will move into the paste mode and is used to enter a class and object as companions. For example, class sample. Press Ctrl+D to finish. The :paste-raw command is used to define a package. For example, package ABC. Press Ctrl+D to finish. The :settings command is used to modify the compiler settings. The output shows the default settings. The :replay is used to replay the session using modified settings. Let me quickly show you the steps now. Step 1. Open the terminal and type Scala to start the Scala REPL. Step 2. Type $INTP and press Enter. Step 3. Use the print command to display a message. Step 4. Use the :help command to display the list of commands. Step 5. Use the :load command to load a file of REPL input. Step 6. Use the :paste command to enter a class and object as companions. Step 7. Use the :paste-raw command to define a package. Step 8. Use the :settings command to modify the compiler settings. Step 9. Use the :replay command to replay the session using modified settings.
Key takeaways. You are now able to describe and demonstrate programming with Scala. Define functions, anonymous function, and class in Scala. Use the different types of collections. And describe and demonstrate Scala REPL.